Hey, what's up? What's up, dudes? What's up, ladies and gentlemen? All right. Been a few days again, slacking. Man, this is looking rough. In I only coded three times in the past like 7, 8 days. That's pretty bad, dude. Um, yeah. Anyway, fucking slacking, right? So let's try to get some shit done today. Um, you already know. Let's set our timer real quick, and let's go up to 68. All right, timer set. And what did we work on last time? So we continue working on stable save state function. Specifically decided to change save state schema to use multiple files instead of multiple tables. Gotcha. Okay. We consulted ChatGPT and created a first pass outline of replacement logic. Consulted ChatGPT. Stopped at line 26 and things to do. So let's go over there. Okay, I see. I see what I need to do. I see it. Let's go ahead and we're gonna call this. Well, let's do the session and then we'll give it the title, right? I guess that's a better way. Is do the work first and then like title it based on the work. And we started at, I would say, 425. And, yeah. Okay, so we're going to begin. Well, let's just do the work, then we'll put the log, because I don't want to get ahead of myself with saying what I'm going to do, and then it turns out that's not what I actually did. See if we can get this, the rhythm of the night. One of the best like beats ever. Let's just do the work, then we'll put the log, because there he is, dude. Holy moly. Alrighty. Let's see. One of the best like beats ever. There we go. There we go. There it is. It works. Cool. Okay. Back to it. Let's see. Stable state function, checkpoint ID. Why am I over here? Let's look at next task. Okay. Remove all code associated with multiple tables. Hiccups here. Remove all code associated with multiple tables. Add code for multiple files. Determine how exactly to copy transfer data from file to file, database to database. Implement logic associated with copying and transferring data from file to file. Review all code. Okay. Let's see. I've been out the game for a minute, so I gotta read this. Revise save system backup schema to use files instead of multiple files. Have 3 database files. Save data, temp backup. Okay, I'm remembering now. It's coming back to me. Save data, temp backup, and then backup. Save data is current unstable. Temp backup is checkpoint stable unless corrupted. Right, because it could get corrupted when transferring from save data to temp backup. But if it's successful, then we do a backup of the temp backup, which is just called backup, and that if that's successful, like, wait a second, is that necessary? Hold up. So we have unstable, then we have a temp backup. But I'm like, do we really need a third one? I mean, I went through the thought experiment last time, but I just want to make sure. Did we actually do this like correctly? Do we need 3? So obviously we need the backup, but do we need the secondary? What is that for again? Like, if this one's successful, then, I mean, it was successful. If it got corrupted, then it got corrupted. Like, there's no... Why did I say we needed a third one? Let me read this. Transfer copy from save data to temp backup. If this gets interrupted... Unless first time operation. Okay, right. Okay, it's like the previous backup. I get it. Okay. So, yeah, I see. It's just in case this one gets corrupted, we can't load from save data because that's always current and probably unstable, like not, not a stable backup. And then backup would be, the last time we ran this system previously. Does that make sense? So if this one gets corrupted with the current iteration, it gets interrupted and therefore corrupted or whatever, then we would go to, we would load from backup. So we do need this third one, I think. Maybe like we might not ever actually use it, but theoretically we need it. So let me write something down real quick on my hand so I don't forget. My fucking electric motorcycle, man, this is embarrassing, honestly. I ran out of battery, dude. I had to walk I had to walk home from work for the most part. I don't live far from my job, but fucking motorcycle broke down. It's a battery thing. The way they designed it, it's bars instead of percentage, and it shows you a higher amount than what it actually is. It kind of will trick you into thinking it's got more charge. I should have known better personally. It's kind of my own fault, but it showed that that it had 4 out of 5 bars. But I'm an idiot, so I had to pay the price. Anyway, I had to write that on my hand because I have it's charging right now but nearby where it broke down, so I have to go get my friend to bring me to go pick it up later so I can drive it back once it's got a little charge. Anyway, okay, if this gets interrupted, load from backup on DC transfer copy, blah 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 blah. Always allows for always having stable save version. I would say that should be having, not have. Okay, so let's go ahead and do this. We're going to go over here to save logic, and it kind of sucks that I'm not going to be using the 3 tables anymore, but it is what it is. I'm trying to think of what other... is there going to be any other file affected by this? I don't know. I don't think so. I think it's probably just this file. So what I'll do is I can create a new backup file. Isn't that what you do? We go to File and then Save As, and then we just write save logic dot back. And then we save this. There you go. So this was actually created for 725. The purpose is to change this. Made immediately prior to what is this? Oh yeah, conversion of save logic pi we'll call it the 3-table system, 3-table save system to 3-file. Did I just do? Oh, okay, there we go. 475 created 4725. Purpose made immediately prior to conversion of 3-table save system to 3 files. 3-file system in save logic pi. For reference in case new system is flawed or I need to review this form. Yay. There we go. Okay, so now we have the backup and the actual file. So we're gonna close out the backup file. And why is this not auto-saving? Do we not have autosave on? So ASD, let me see. So if I open this back up, okay, so it did autosave. Weird, because when it shows italics on the file tab, that means it's not saved. And for some reason, it was showing like that it wasn't saved. Anywho, okay. We're supposed to have a third. There we go. All right, what are we doing here? What are we doing? Okay, so now this one's gonna be refactored. I guess we'll just start from the top and work our way down. Okay, so we're not gonna have. And does it? Okay, yeah, this is what creates the database. I forgot for a second. How do you create the database file? Well, this will create it if it doesn't. And it enables auto commit. So that means we're gonna have multiple cursors, right? Yeah. Whoa, wait a second. Doesn't. Okay, so this is a question of how we're gonna actually do the file operations. Are we going to how are we gonna do this? I guess we should, yeah, we should create the database files here. That would make sense. But as far as whenever we actually save to the database files, I remember I had pulled this up and queried about this in Shippity Jippity. And we got some. Here we go. Database backup versus table. Okay. Yeah, we had a lot going on with this session, prompt session. And I asked a bunch of different things, and I think we ended up deciding to use vacuum into. And I think that one of the last things I asked was, what was the difference between vacuum versus vacuum into? Let's go back up here. Okay, yeah, we didn't want to use util because that requires manual fsync flushes and shit, and we don't need to do that. We don't want to have to do that. What happens if vacuum into line crashes in the middle of operation? If vacuum into crashes in the middle of the operation, your main database remains completely intact and unaffected, but the backup file will be incomplete or corrupted. So it's safe as far as preserving the original file, which is good. You want that. Why does the main database save vacuum into creates a new file instead of modifying the existing one? Unlike regular vacuum, which rewrites the same database file, vacuum into creates an entirely new database file. I don't understand why this would mean that the main database wouldn't be safe, though, if we used vacuum instead of vacuum into. What does backup have to do with the main database? ChatGPT might be tripping. Since game data is only being read and not altered, it remains safe even if the process crashes. Yeah, it's tripping. The backup file, backup DB, is built atomically. SQLite writes data into backup DB in structure manager. Okay, so I think the difference between vacuum versus vacuum into is just it creates a new file. Vacuum into does, but vacuum just vacuum writes to an existing file, I think. Let's see. So if using wall mode and then vacuum into, it avoids these potential write delay issues. Vacuum into completely avoids these write delay issues in wall mode. Unlike vacuum into ensures that all data, including uncommitted write-ahead logging writes, is correctly transferred to the backup file in a fully consistent state, which is very important, actually. Yeah, that's actually super important. Why vacuum into is safer in wall mode. No need to manually run pragma checkpoint. Vacuum into automatically includes all write-ahead logging data in the backup. There's no risk of missing recent writes. No OS level. Yeah. Reconstructs a fresh database file using SQLite's internal logic. It does not rely on the OS file system's ability to flush writes correctly before copying. Wait, what? Reconstructs a fresh database file using SQLite. It does not rely on the OS file system's ability to flush writes correctly. Okay. That's pretty much it. Needs to be running for every file copy. So auto commit. I'm just like I'm vacuum into does not block readers writers. I'm reviewing this here. No concurrency, yes. Beautiful. Vacuum into backup DB creates a clean backup of the database using SQLite. Which is better for you? If you want a quick full backup with minimal coding, use file copy or vacuum into. Okay, yeah, so we determined that the multiple file thing is just better in general. Alright, so now the last thing I really need to know would be vacuum versus vacuum into. Let's see. Great question. Vacuum and vacuum into both serve similar purposes, defragmenting and compacting the database, but they work quite differently. So, vacuum. Well, let me make sure I clarify for SQLite 3 because it's giving me. You got to be specific. You got to be specific, dude. Otherwise, you're gonna get some weird ass response. It's gonna think you're talking about SQLite from 10 years ago. What the fuck is this, man? What the fuck is this, man? Whoa, dude, nobody fucking press play, dog. TV's tripping, dude. Oh, okay, baby. Let's do this. Okay, here's a clean, fresh, crash-safe, and wall-aware SQLite 3 backup utility function using vacuum into. See, it's taken into context my previous my previous prompts. Tailored to your use case. Python plus SQLite 3 plus safe game data backups. Ooh, slick. Safe SQLite backup with the vacuum into. But that ain't what I asked it, dude. Here we go. Just go back up here. Man, ChatGPT's the GOAT, eh? Alright, here we go. So vacuum rebuilds the entire current database. Okay. Rebuilds the entire current database to remove fragmentation. It compacts the file size, and it applies schema changes to without row ID tables. I don't know what that means, honestly. It creates a new temporary database file in memory or on disk, rewrites everything there, then replaces the original database. Oh, okay. Okay, so you would run vacuum in a database file or on a file, and that would rewrite the database, that database file, and then it just replaces the original one. And the purpose of that is for what? I don't know. What's the purpose of this? It locks the database during the operation. No reads or write aloud. Risky if the process crashes. Partial vacuum can lead to corruption if not on a journaling file system or if power fails mid-operation. The less common with write-ahead logging plus journaling. Ooh, see, now I'm pretty sure I'm using both write-ahead logging. Okay, so journal. I thought what write-ahead logging was the journal mode. Huh. Rebuilds the entire. Okay. Risky process crashes. Partial vacuum can lead to corruption if not on a journaling file system or if power fails mid-operation. They're less common with. Optimizes your current database, reduces file size, and improves performance. Blocks all database access during the operation. If it crashes, the main database could be affected in edge cases. You cannot specify an output file. It affects the original database. So it defrags and compacts. Gotcha. Okay, I understand now. Vacuum into is copies the current database into a new file, performing the same defragmentation and compaction. Okay, so that's cool. Designed for safe backups and or rebuilding. It reads the existing database and writes out a fully rebuilt version to a new file. Does not modify or lock the original database. Other operations can continue. If it crashes, only the target file backup.db is potentially affected. The original database is untouched. Doesn't block rewrites on the source DB. Good for creating consistent compact backups. Much safer with write-ahead logging mode than shoot to the copy file. Requires SQLite 3.27 and doesn't reduce the size of the original database. It just makes a compact copy. Well, how could it be a compact copy, dude, if it don't reduce the size? I mean, I don't really care, but whatever. When you use what? Use vacuum when you're shrinking, creating safe backups. No. Working without no. Cry safe rebuilds. Use vacuum into to create a safe backup to work with a lot. We don't need that. You're using wall mode, yes, and then crash safe rebuilds or copies. Yes, that's what we want. Okay, so if you're building a game to figure the right, you vacuum into is ideal. It's not blocking. Okay, so what if we... Let's see what it got here. See, safe SQLite backup, source database, and then the backup path. Safe backup a SQLite database using vacuum into, source database string, path to the source database file. Path to the source database file. Why didn't I do it like this? See how they put source DB and then parentheses string to designate the type? Why I didn't do it like that? I wrote like type colon whatever type it is. Silly goose. Save the backup. So source database string, path to the source database file, backup path string, desired path for the backup file, and it returns a bool true if successful and valid, false otherwise. So temp backup equals backup path plus .tmp. Why would we use a TMP file though? What's the difference between a TMP and an actual database file? And .tmp file. Okay. Verify the backup is valid. With SQLite 3 connect temp backup as testcon. Let's wait. Connection equals SQLite connect. Is it connect to the source? With SQLite 3 connect temp backup as testcon. Result equals testcon execute. Pragma integrity check. Result is not equal to OK. Verify the backup is valid. Okay, but why would we verify that the backup was valid prior to making the running the backup? Like replacing, you know, making the backup, remaking it. I guess maybe because if you tried to do that with, and it was like corrupted for whatever reason, that would throw an error. Like it would mess up the process. Let's ask that. Okay, so what's the difference between a DB file and a TMP file? Why do we verify if backup is valid prior to replacement? Okay, and then what was the other question that I had was fuck. Damn it. I can't remember. What was the other question that I had, dude? I just 17 database file. Why do we verify? Man, there was a third question. I hate when that happens. That's why I gotta get more sleep at night, bro. It's bullshit. Oh wait, no, it doesn't. It vacuums first. Oh, okay, I'm tripping. Let's see. I didn't actually read this. Connect to the original database. Okay, so this connects to the source database. This runs execute vacuum into temp backup. So this actually creates the temp backup. Copies the original database into temp backup, and then when we're done we do an integrity check. Okay, that makes sense. At least I was on the right track with understanding why it was gonna do that prior to actually replacing it. And then it uses OS replace temp backup to the backup path. So that's only if you want to, like, make the new one replace the old one. But if you want to keep both of them, which is what I would want to do, then we wouldn't even run that. We would just leave, we would leave it as is and have two of them. OS replace temp backup path. Exception is E if os.path exists. Okay, so that would throw an exception. If we did vacuum into, apparently it would, if they're using this in the code to handle the exception. And in this case, if that backup file already exists, it would remove the temp backup. So why do we have to do that though? Let's see. Why do we have to run that code? Would it throw error if file already existed? Does os remove do? Does os remove do? And it's gonna know what I mean. Does os remove do? Alright, let's see. What is the database file and TMP? Functionally, there's no difference. Both database file and TMP are just file extensions. SQLite doesn't care what the file name is, as long as it can write to it. Okay, in the context of our code, the TMP file is a temporary intermediate backup file. I mean, we don't want it to be called TMP though. We're gonna be using it as a non-temporary, like. It don't fucking matter, honestly. We're not gonna use TMP anyway. We don't want to overwrite an existing good backup until we know the new one is valid. Okay, that actually makes sense as far as at least like the naming. So the temporary one would be the first one, and the real backup non-temp namespace would be the one that's like, overwritten later. But that could get interrupted too. So I don't see that you could say one way or the other that one of them is going to be like the good one and the other one could be the bad one. It depends on, if they get interrupted for whatever reason. If on one run the temp gets the first one gets interrupted, then that one's no good and you got to revert back to the second one. But in the case of the second one, it gets interrupted. In that case, you would have to revert back to the first one. So we're just gonna. It don't really matter. We'll figure out the namespace. I just wanted to clarify that we don't have to use TMP. If the operation fails halfway with the file script, we don't touch the real backup. Only the TMP file is affected, and that doesn't matter if it's a TMP or not. Working copy used during the backup process. Okay. Once the TMP backup passes the integrity check, we rename, atomically move it to overwrite the old database file. Okay. Why this code exists? Okay, so catches any error, SQLite connection errors, write errors, disk full permissions. If OS path exists, temp backup checks if the temporary backup file was created before the error occurred. OS remove temp deletes the TMP file if it exists. This prevents leftover junk from building up if something goes wrong. OS remove deletes a file. It does not throw an error if the file doesn't exist, because we're checking with OS path exists first. No. Why is it necessary? If you didn't do this, a failed backup attempt could leave. Let's see. If you didn't do this, a failed backup attempt could leave an incomplete or corrupt TMP file. No, 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 no. It didn't understand. I mean, why do we... Why do we have exception for... What's the code that I'm thinking of? Let's see. On that. Would that throw an error if the temp backup file already existed? Or would it just overwrite it without throwing an error? You're wondering if this line would throw an error if temp backup already exists, and thus whether the accept exception is even necessary in that case. Yes, it would throw an error if the target file already exists. Specifically, SQLite 3 operational error file is not empty. SQLite's vacuum entity refuses to overwrite an existing file. It wants the target file to not exist before starting. If the file exists, vacuum will fail with an error, so that's when you try except to catch that error, clean up any partially created file in case it was written partially before failing, and prevent the program from crashing or continuing with a bad backup. What happens if you skip the check? If you didn't catch the exception and the file already exists, if you didn't catch the exception and the file already exists, your program would crash SQLite. Operation error, the backup would fail. You might leave a dirty DMP file lying around. Options to handle it. If you wanted to ensure it always works, you could delete the file before vacuuming. Well, so let's think about this. If we run so the way that this would work in our application is we would save data to the save data table in, we'll just call this, we don't actually have a name for what we do, we would in save file database. Now, whenever we then eventually hit a checkpoint, a save checkpoint, we would run stable save state function, right? Okay. Now, in that case, that's when we're going to save the data. We're going to transfer from the save file database over to whatever we call the second one. Like, you know, it doesn't really matter. We would just call it save file stable, and then we'll have save file backup. Those are good names, I guess. So whenever we went to do that, to vacuum save file database into save file stable, that would, like, think about this, would we delete the file first? Because we can't like, we can't have two of them. You can't run it on a file that exists. So, like, we would have to, I guess the smartest option would be to check if the file exists. So if it's the first time that's running, if it's the first time we're vacuuming save file to save file stable, then that would, we would check to see if that OS file path exists. in that case, it wouldn't exist. So then we would just run vacuum into. But then else, if the file did exist, and since that is a stable backup, and because it might not be, it might be our first time creating a backup, which means we might not have the save data backup, you know, the secondary backup file created. So in that rare scenario, we would need to basically duplicate the save file stable to like a new file, basically create a copy of it, and then we would go ahead and delete the original. Does that make sense? Or couldn't. So there's a couple different ways to do this. We could either, prior to vacuuming save file to save file stable, we could in the case that the file already existed, save file stable that is, we would just do the same thing to that file. We would create a backup of it by using vacuum into on that file, and creating a backup, then deleting the original, and then running the vacuum save file to save file stable. I know that's kind of confusing, but that will ensure that if the process got interrupted, we could revert back to that backup. And anytime after the first time, I don't think we would necessarily have to do that, because we would have the secondary backup already. Does that make sense? Because we're just making sure that we have a stable save file to fall back on at all times. And if it's the first time that it's being run, then you don't have that secondary one. So you need to basically double up, clone. Well, actually, if save file stable already existed, in the case that save file stable already existed, when we ran the save file to save file stable vacuum, yeah, so I need to flesh the logic out. There's a couple different ways to do it. It's kind of like, you know, it could. There's a lot of different ways to do it in practice. But ultimately, if the file already existed, if we had already created a backup once before, we could run the vacuum into without a hitch. But if we haven't done that yet, like, we could just straight up, well, the file wouldn't exist, but I gotta like write this out, the process. So let's go ahead and do this. Now that I know what code I'm actually going to use, we're going to use vacuum into. Let me copy this. So we're not going to have multiple tables. Where should I put this at? Visual data say no. No, not in this one either. Loop data, no, not that one. Here we go. Stable save state function. This is where it would be different. So let's go ahead and add this code right here as just like some placeholder code. Let's just say sudo code / chat GPT code for copying one database file to another. Note, let's just put note that the database file the temp backup database file cannot exist for this to work, i.e. it would have to be deleted. Prior to running this line. It will throw an error, so we need to handle exception. Alright. And I'll write some more notes down here. Add logic to add logic for what? Well, to vacuum from save data database to, we'll call this save data stable database, and then we're going to need to add logic to vacuum from save data stable to save data stable backup database. All right, but in between that, we need to, if first time running, just put the note here. I'll put ensure below logic exists in try except to catch whenever the, well, we wouldn't need to have a try except if we checked if the file existed first, right? Like if we check to see if it exists first, the one we're vacuuming into, then since we would need it to not exist, we would just check to see if it exists first. If it does exist, then we would delete it. But this was where I was getting that complicated scenario. But let me write this down first. So ensure below logic, we'll say check to see if save data stable.db exists using if os.path exists save data stable well we would need the like path if O exists path save data stable. Okay, check see if save data stable exists. If it does, then must be deleted prior to vacuum into IMO. No, that's not right. Into. If it does, then must be deleted prior to vacuum into. Before deletion, must create copy by vacuuming into save data stable. We'll call this just like save data stable. We can't call it backup because, I mean, technically that's what it is, but so let's run through this scenario. So we check to see if save data stable exists. If it does, it has to be deleted prior to vacuum into. So if it's not our first time running it, that means it already exists. Therefore, it must be deleted prior. Namely, we have to delete save data stable before we can recreate it, basically. And we're saying that before we delete it, we must ensure that there's a copy created, you know, of it. But if the entire process involves conversion from save data to save data stable, and then we go from save data stable to save data stable backup, we already got past this point. So that means we would in the case that this already existed, i.e. if it entered true into this if OS path exists save data stable path, that means we've already done this, which means save data stable backup exists. Does that make sense? Because it's like a 1, 2, 3 process. If you know, if 2 exists, then 3 happened already because of the way that the process works. So before deletion, we must create a copy. So we wouldn't actually have to do that. That happens after so in the case that the save data stable database does exist, we could just safely delete save data stable and then run vacuum into from save data to save data stable, because save data stable backup would already exist. Does that make sense? There's no scenario where save data stable would exist, but save data stable backup would not. Does that make sense? Unless, you know, there's like a 1 in a trillion scenario where save data stable got successfully created, but then it got interrupted prior to the save data stable backup creation. So in that case, in that case, yeah, you would have to create the backup. So I guess maybe we should have it. Just like, wait a second. Yeah, I mean, technically, yeah, technically there's a 1 in like a trillion scenario where this could happen, where save data stable exists, but like it got interrupted. We vacuumed from save data to save data stable. Then when we went to vacuum from stable to stable backup, it got corrupted, and in that case we would have to, upon running this, we would need to create a backup of save data stable prior to deleting it, because we don't technically have a backup. Okay, so yes, then the logic becomes a little bit more specific and complicated. So we would check to see if OS path exists for stable. If it does, then it has to be deleted. But before deletion, we must create a copy by running vacuum into save data stable. But this is, let's see, before deletion, we must create a copy by running vacuum into save data stable backup dot database if let's see, so we need to rephrase this a little bit. So yeah, the process check to see if save data stable exists first of all. If it does exist, then it has to be deleted. But before we delete it, we need to check to see if we need to check to see if if save data stable backup exists and is valid. So let's break this down a little bit. Let me say if save data stable db exists, then we check if it's valid. What's the term, the code, like the actual code for this, where we validate it, like to make sure it's if save. Here we go. Integrity check. So this is what we need to do. We need to do dot execute integrity check fetch one. Check if save data stable is valid using to ensure it is stable prior to deletion of save data stable. DC, DB. There we go. And then we'll say if stable, then wait. If it does, check to see if save data stable exists. If it does, then we check to see if save data stable backup exists. Yeah. So we check to see if save data stable exists. Then we check to see if save data stable backup exists. And we'll just do this same exact thing. Alright. And then check if save data stable database is valid. No. Well, we do need to check. We want to make sure it's got integrity prior to creating a copy. So there's kind of a lot of like double. It's a little bit of double, you know, of the same process. It's a little bit complicated. It's not really that complicated. It's just kind of like ones and twos, a series of ones and twos. So check if save data is stable. That does need to happen. But that would not happen at this point. First, we check for stable. If it exists, it must be deleted prior. So then we would check to see if the backup exists. And if it does, so we'll just say if it does exist, we would then do this. We would check to see if save data stable backup database is valid using pragma integrity check to ensure is stable prior to deletion of save data stable. Now that is correct. So we're checking to see since it does, the backup does exist. We're just checking to see, in the case that it does, if it's stable. And then, so if it is stable, then we can, then what? Well, then we can go ahead and finally delete save data stable. .database, right? Isn't that, yeah. Because the whole process here is we're trying to copy from save data to save data stable. So now we know save data stable it previously existed. Then that means, okay, we need to check to see if save data stable backup exists. If it does exist, then we need to check to see if that backup is valid and it has integrity. If it does, then we know we have a safe backup in the case that this process fails. So then we know we have one of those safe backups. We can delete the save data stable database entirely. And then we can vacuum into save data stable. I know that's like a lot of word salad, but that's what has to happen. Yeah, so if stable deletes it, and then we would vacuum into save data stable database. Yeah. Then, so add logic to vacuum into from save data. This little like section I just wrote is this entire little process right here. So like this is all for this you must create copy. Alright, let's review because this is gonna be it. We only got 3 more minutes. Okay, so we have save system add logic to vacuum into from save data database to save data stable database. Right, and that consists of we can get rid of this. This would just be like sub comment for the above section, whatever. So check to see if save data stable database exists, right? That's the first thing, because that's the one we're trying to vacuum into, and it can't exist for that line to not throw an error. Then if it does, and we want to say if it does exist, writing it in pseudo Python. This is how you do it. You write it in plain English, and then you slowly convert it into actual code. That's how I do it anyway. It works pretty well. So if it does exist, then it must be deleted prior to vacuum into. And we'll just like make this a little bit more specific. We'll say save data stable must be deleted prior to vacuum into. All right. Then, since we know stable exists, we would then check to see if backup exists. If it does, all right, then we'll say check if the backup is valid. But shouldn't we check to see, well, it doesn't really matter if it's stable, right? Because we're about to delete it. So that doesn't really matter. We need to make sure that the backup is stable and valid. So that's all we need to check. So if stable exists, check to see if backup exists. If backup exists, check to see if it's stable. If it's stable, just kind of like trimming this down to make it a little easier to read, so I'm not confused when I read it next time. So if exists, check if it's valid using pragma, and then we just say if stable. Then we would delete save data stable entirely, and then run vacuum into save data stable database. Yeah, there we go. There you go. That's it. Like that's I think that's everything that would need to happen. I guess we could check to see if at that point if save data stable is stable itself after the fact. I don't know why it wouldn't be, but I don't know, maybe we should just do that. I feel like we might want to do that to be safe. For safety, check to see if new just created, can't type, save data stable db is valid using this. I mean, I guess it's good practice, right? To just verify. Safety check, see, because yeah, I guess we should do that because this ensures that, like, basically after this point in time, if we disconnect, we're gonna assume that it is valid. So when we try to reload from it, or when we reconnect, we're gonna assume that it's valid and try to reload from it. If it's corrupted, well, I guess you could say we could check prior to loading in to make sure it is valid, but I think it's better. It's called like, it's like quality control after the fact. You want to make sure the quality is good before you like assume that it's good, instead of like letting the customer get it, aka reconnecting and then testing to see if it's valid. That's like backwards. Yeah, so I think the proper location for that validation check would be immediately after it's created, I guess. Yeah. All right, and then the other one would be to add logic to vacuum into from stable to save data backup. And then, so this is basically going to be the same exact process. Actually, the same exact process as immediately above, except using different namespaces. And this is where we're going to stop. 4725. Let's just put that stopped here. Alright, so let's copy this. And this is line 111 in save logic. So let's go over to devlog. And let's get rid of that first. And go here. And then get rid of this. So it stopped at line number 111 in save logic. What? Pi. There you go. Okay, and the time is going to be 5:38, and then we're going to stage commit and push our changes, and that's going to be 5:39 to 5:40. Alright, so this is 4:25 to 5:40. That's going to be an hour and 15 minutes exactly, so 1.25 hours. Our title is going to be Save System Stable Save State Function Revision. Yes. We'll just put began first pass revision converting save logic dot stable save state function. And first pass revision converting saving 3 table system to 3 file system. Yeah, there we go. I think that's pretty solid. I feel like something's wrong with that. I don't know. I might just be tripping. I'm a little tired here. I didn't sleep. I only slept like 4 and I don't know if I slept 5 hours last night. Some people can do that. I can't do that. My caffeine is wearing off, and I'm like, my brain is fizzling out. All right, so we are in the root of the project, the root directory of the project. We are on the correct new feature branch. So now we're going to do git add to add everything. We're going to do git commit -m double quotes, paste in our devlog message, our title being save system stable save state function revision. And I guess we could call this part 2, but it's fine. Alright, so we created the save logic backup file, which is correct. We had 150 insertions, 5 deletions. Okay. And I'm pretty sure 150 stands for lines and not characters. Maybe it is characters. I always forget. I always get mixed up on that. It's not important. Anyway, git push. So let's push to upstream. So we successfully committed. Now we're pushing to upstream remote GitHub branch, and that successfully worked. Now we can go ahead and exit this out, and we're gonna go to open this bad boy up. We're gonna go to programming, projects, Canasta. We're gonna copy this one. We're gonna back out. We're gonna go to backup, exit, delete the old one, paste in the new one, enter into it, go all the way to the end to verify today's date. Yep, so this is up to date. We can now back out all the way to right here, and we'll say 4/7/25 to reflect today's date. And that's it, guys. So decent progress. You know, it is what it is. It was only an hour, a little over an hour, but better than nothing, right? So I gotta go pick up my motorcycle, and yeah. All right, dudes. I'll see you next time. Probably not gonna do another session today, honestly. I'm pretty tired. So